Hi everybody. Since we are not having class tomorrow, I decided to make this video that will help you prepare for the test that you are still going to have on Monday. In this video, I will go over some questions that I think will serve you well on the exam. So yes, even though we're having e-learning day on Friday, it is still a school day, and your task for the day is to review this video, go over the problems so that you are prepared with the exam that you will still have on Monday. Okay, so let's get started. Now notice that even though that this slide here says that this window here says that's less than 11.1, I kind of tricked it so it's doing all of the problems that will serve you well in Chapter 4. And yes, this is a subset of the problems that are on the web test. And here is our first problem. We have the equation 3x plus 6y is equal to 8. And we have this ordered pair where we're missing the y-coordinate, and we need to figure out what that is. So let's go ahead and do that. We have 3x plus 6y is equal to 8. And we have the point 3 question mark. So that tells me that x is equal to 3. And we need to figure out what y is. Okay, so we're going to substitute 3 in for x. That will be 3 times 3 plus 6y is equal to 8. Okay, well 3 times 3 is 9, so it's 9 plus 6y is equal to 8. And we want to solve for y, and that basically involves getting y by itself. To do that, we need to get the 9 term on the other side, and that involves subtracting 9 from both sides of the equation. So I'm going to subtract 9 here, and I'm going to subtract 9 here. Adding vertically, these cancel. I just have 6y. Over here, I have negative 1. Now I want to get the y-coordinate. I want to get the y by itself by making the coefficient become 1. I can do that by dividing this side by 6. Then you divide this side by 6. These will cancel. And I will have y by itself. That's what I'm looking for. And y will be equal to negative 1, 6. So y should be negative 1, 6. For my fraction, negative 1, 6. There you go. Let's move on to the next part. In the next part, we have the exact same equation, but now we have the point question mark 3 over 2. Okay, so we know that y is equal to 3 halves. We need to figure out what x is. All right, so we're going to substitute that. We're going to substitute this value in for y, and that will give us x plus 6 times 3 halves is equal to 8. Now we can simplify this using a procedure that I've used before. This is going to be 6 divided by 2, which is 3, times 3, which will give you 9. So this is going to be 3x plus 9. Once again, 6 divided by 2 will give you 3, and then 3 times 3 is 9. You can also look at it from this point of view. This will become 1, that will become 3, add and multiply them together, you have 9, and all of that's going to be equal to 8. Now, once again, I want to solve for x. That means getting x by itself and everything else over here. So the first thing we need to do is use addition or subtraction to move the 9 term onto the other side. So minus 9, minus 9. These will cancel, and over here we have 3x. Over here we have negative 1. And then finally we can get rid of the coefficient by dividing both sides by 3. These will cancel, and we will have that x is equal to negative 1/3. Over here, fraction, negative 1, tab, 3, and let's hope this is right. It is. Okay, we can move on to problem 2. Now here we have once again an equation in standard form, and we need to fill out this table. Oh, actually, not correct. My stand corrected. My equation is in slope-intercept form. We have y is equal to 2x minus 4. Now, for the first table, we have that x is equal to 2, at least in the first row, and we need to figure out what y is. Okay, well, that is going to be y is equal to 2. We're going to substitute 2 for x, so it's 2 times 2, minus 4. Okay, well, 2 times 2 is 4, minus 4 is equal to 0, so y will be equal to 0. So we can put a 0 in here. For the next problem, we have that y is equal to 2. We need to figure out what x is. Okay, well, we're just going to substitute 2 in for y. Using this equation, we're going to let 2 be y, and then we have 2x minus 4, and we need to figure out what x is. Once again, we want to get x by itself. That means we need to move the negative 4 term to the other side. We can do that using addition. Plus 4 here, plus 4 here. 2 plus 4 is 6. These cancel. We have 6 is equal to 2x. And then finally, we can divide both sides by 2. These will cancel. 6 divided by 2 is 3. We will have 3 is equal to x. So x happens to be equal to 3, and we could put a 3 in here. And there we go. We are correct. Okay, so that is 2 down. Oh no, I think we have more here. Oh, here is part 2. Now in part 2, we actually need to plot those 2 pairs. Now what are those 2 pairs? Well, in your test, you can actually go back and look. But what we should have are the points x is equal to 2, y is equal to 0. That will be 2, 0. And here we have y is equal to 2 and x is equal to 3, 3, comma 0. Now in your homework, if this was a homework, since I have this set up like as a homework, it is right there. If it was a web test, you could just go back and look because you can move around. So for this particular one, we want to grab our point at the origin and move them to the appropriate places. So the first one should be 2, 0. So we're going to go down the x-axis 2 and stay put. And then actually the last one is not 3, 0, it is 3, 2. That was a mistake on my part. The eraser mode is not working. Well, fine. We can fix that. So the next one is going to be 3, 2. So we're going to go 3 on the x direction, 2 in the y direction. That should be our graph. Let's make sure that's right. Okay, good. And then we can submit our answer. And there we go. Now we can move on to the third problem. Now, here, you want to graph the line by locating any 2 ordered pairs that satisfies this equation. And if we have to, we need to round to the 1,000th. Now, notice that this is the equation for a line in slope-intercept form. Okay, this is the slope. This is the y-intercept. So one point is going to be the point 0, 2. Remember, the y-intercept is that point where the slope crosses the y-axis, and that would be right there. So the first point that we can immediately write down is 0, 0, 2. That is one of our points. Okay. Now there's a couple of ways that you can figure out the next one. The first way is you can let x be equal to the value in the denominator. So the value in the denominator is 3, so let's let x be equal to 3. If we do, then we can have that y is equal to negative 1/3 times 3 plus 2. Okay, well, 3 times negative 1 is, or 3 divided by 3 is 0. No, 3 divided by 3 is 1 times negative 1 is just negative 1. Plus 2 is going to give you 1. So if x is equal to 3, y is going to be equal to 1. And our next point is going to be 3, comma 1. Okay, so we can put in a 3 here and a 1 there. Now there's another way you can do this. Notice that our slope, typically call that m, is equal to negative 1/3. Okay, this is the rise, this is the run. So here the rise is negative 1 and the run is 3. Now the negatives, the sign here determines whether you want to go up or down. As far as the run is concerned, we always go up the x-axis. So we can start here at our known point. Our rise is negative 1, go down 1. Our run is 3, 1, 2, 3. That is the exact same point. So there's two different ways to get the exact same value. You can either put in the same number as the denominator and you'll get something that's nice and neat, or you can look at your known point and then just do rise over run. Either way, they both give you the same answer, and they are correct. Okay, we are down now. We're up to 4. And here we want to find the y-intercept and the x-intercept for this linear equation. Okay, so we have 6x minus 7y is equal to negative 4. Okay, so x-intercept. Oh, wait, let's do y-intercept first since that's the top one. Y-intercept. To find the y-intercept, we need to set the other variable equal to 0. And then we want to solve for y. Okay, so if x is equal to 0, we're going to have 6 times 0, which is 0, minus 7y is equal to negative 4. Okay, now we want to isolate y. We're solving for y, so we need to isolate y by getting rid of that coefficient. So we're going to divide both sides by negative 7. All right, these will cancel. We have y all by itself, and over here we have negative 4/7. But the negatives will cancel, and this is just simply 4/7. And it's probably in your best interest to put this in as a fraction. So notice when x is 0, y is 4/7. So we're going to have the point 0, comma 4/7. And let's go ahead and put that in here. X is going to be 0. Y is going to be 4 divided by 7. 4/7. And there's your point. Notice that the y-intercept is on the y-axis. And that should make sense because that is the point where this thing will cross the y-axis. All right. Then finally, we want to figure out the x-intercept. The x-intercept is that point where the line crosses the x-axis, and that occurs when y is equal to 0. So we're going to set y equal to 0, and we're going to figure out what x is. In that case, we are going to have 6 times x minus 7 times 0 is equal to negative 4. Divide both sides by 6. Because remember, we want to isolate x. This will cancel. We will have x is equal to negative 4/6. Now notice both of these, both the numerator and the denominator have a common factor. That common factor happens to be 2. I can write this one as negative 2 times 2. And over here I can write this as negative, no, it's positive, 3 times 2. These two will cancel, and we have our simplified fraction of negative 2/3. Okay, so when x is equal to negative 2/3, y is equal to 0, and that is our x-intercept. So here we can do fraction negative 2 over 3, 0, And there's our other point. As you can see, it's on the x-axis. They actually are kind of tight, but hopefully it's correct. And it is. Moving on. Okay, here's question 5. Here we want to find the slope and y-intercept for this particular equation. All right, so what do we have? We have y is equal to -3/2 x plus 2. Also notice that this equation is in slope-intercept form. This right here is the slope, and this right here is the y-coordinate of the y-intercept. So the slope is this value right here, -3/2. And the y-intercept, or the y-coordinate of the y-intercept, that's right there, that is 2. Okay, now we need to graph this. Now remember, the y-intercept is 2, so one of those points is going to be the point 0, 2. It's right there, or if you're taking a test, you can just go back and look. And our slope is -3/2. All right? And remember, we can interpret -3/2 as rise over run. So our rise is -3. Our run is 2. Okay, so we can basically start by first plotting our y-intercept. That's actually what they wanted us to do anyways. So that is going to be the point 0, 2. 0, 1, 0, 1, 2. There it is. And now we can submit our answer. There we go, we're good. For the next one, we want to plot one additional point, and this is what we can do. Remember, our y-intercept is going to be the point 0, 2. There it is. We know what our slope is -3/2. We have a rise of -3 and a run of 2. So we can start at our y-intercept, which is right there. We can go down 3, rise of -3, 1, 2, 3. Run of 2, which is always up the x-axis, 1, 2. That should be our second point. Notice it's crossing the intercept, and we're right there. That should be correct. And there you go. So rise over run is a very useful tool for solving some of these problems and doing them quickly. Okay, next we have this, and we want to find the equation for a line, particularly in slope-intercept form. All right, so we know that the slope is 3/2. And we know that our point is 0, 3. So we could immediately look at this and decide to use the point slope form. And that probably would be the safest thing to do. You could actually go ahead and use the slope-intercept form because this is a slope and this is the intercept. But if you're not sure, the safe bet might be to do y minus y1 is equal to our slope times the quantity x minus x1. That would be the safe bet, okay? This, of course, is x1. That, of course, is y1. So that's going to be y minus 3 is equal to 3/2 times the quantity x minus 0. All right, well, that's not a problem. This is just nothing more than 3/2 x. Here we still have y minus 3. We can add 3 to both sides of the equation. These will cancel. We have y, and that is going to be equal to, these are not like terms, so they cannot combine, 3/2 x plus 3. And that's what we should go, that's what should go in here. Y is equal to 3, oh, not that, fraction first, 3/2 times x, don't forget the x, that'll mess you up, plus 3. Okay, now it is true that, remember, this is the y-intercept and this is and that's the slope. So if you could also recognize this as the slope and intercept and immediately use the slope-intercept form, which would be y is equal to mx, m is 3/2, plus b. It's, oh, well, b is not that, b is 3, sorry about that. So if you are comfortable with the idea of this being slope-intercept, you just go ahead and do that. If you're not, I would start with point slope and then do the math. It's not that much math to get where you need to go. Okay, now we need to plot it. First, we need to determine the graph for the line, and they gave us the y-intercept. There it is. So now all we need to do is come up with another point. Once again, we can interpret the slope as rise over run. So we have a rise of 3 and a run of 2. So starting here, rise 3, 1, 2, 3, a run of 2, 1, 2. That is your second point. And hopefully that will work. Yes. Okay. Here we have the equation y is equal to -4. Okay. Regardless of the value of x, y will always be equal to -4. If you wanted to see a graph of that, part of my axes here, then it's going to look like this. 1, 2, 3, 4. That is what y is going to be. So essentially, it is going to be a horizontal line. No matter what x is, y will be -4. So whenever you see y is equal to -4, you think horizontal. If it's horizontal, then the slope is 0. For the next one, now we need to, I almost forgot, we need to graph the line. To do that, all you need to do is come down to, remember, no matter what x is, y is going to be -4. So if x is 0, y is -4. If x is 5, y is -4. There you go. Okay, now we want to consider the graph and these 2 points. Okay, and we want to find the slope. Now there's 2 ways you can do this. One, you can use the slope formula, which is m is equal to y2 minus y1 over x2 minus x1. Okay, and you can decide which one you want to be 0.1 and which one you want to be 0.2. The other way is to recognize that the slope is equal to the rise over the run. Now when you do this, you want to start at the leftmost point. That would be point A. And then you want to go down to you want to go up or down to your level with point B. So this one we're going to go down 1. So the rise is going to be -1. And then to get to B, you then need to go you need to run up the x-axis too. 1, 2. So the run is going to be 2 and our slope should be -0.5. Now notice that we always want to run up the x-axis, so when you do this, you always want to start with the leftmost point. So we start here, go down 1, rise of -1, go over 2, 1, 2, run of 2. So the slope should be -1/2. If you don't like doing it that way, you can do it algebraically or numerically, and that would be y2, I'm going to call this y2, which would be -7, minus y1, which would be -6, divided by x2, which is 4, minus x1, which is 2. All right, that's going to be -7 plus 6, divided by 2, which once again is -1/2. So our answer here is going to be -1/2. It's down here somewhere. So -1 divided by 2. Now notice for this particular problem, when you hit fraction, you get this fraction format with the red boundaries. When you have that, you can move from numerator to denominator basically using your cursor. If you have them with the black boundaries, you need to actually use tab to move from one to the other. And of course your mouse always works. Okay. We have 3 steps to this bad boy. We want to find the y-intercept if there is one. Okay, well, Remember, the y-intercept is that value where it crosses the y-axis. Well, the y is that point where it crosses the y-axis, and it crosses the y-axis right there, and that is the point 0, -5. So what you want to put in for your y-intercept, you don't want to put in -5. They're going to yell at you and say that's the wrong format. Now, if you did that on the test, I don't know if it would yell at you or not. If you did do that, I would probably dock you like a half of a point or something. You want to put in an ordered pair. Make sure you put in an ordered pair. So that would be 0, -5. And there you go. That's how you would do it. Okay, we are more than halfway there. And then finally, we want to determine the equation for the line. So check this out. We know what the slope is. It's -1/2. We know what the y-intercept is. That tells me that b is equal to -5. So given that y is equal to mx plus b, and m is -1/2 and b is 5, I can write this as y is equal to -1/2 x minus 5. Y is equal to fraction, -1, down cursor, 2, get out of that, x minus 5. There you go. Okay, now we want to write an equation in slope-intercept form giving this particular slope and an ordered pair. For this one, we need to use the point-slope format. Well, that's where we need to start. So that it would be in the point-slope form is y minus y sub 1, and yes, I will have a formula sheet for you, is equal to m times x minus x sub 1. And once again, we have the points 4, -4, and we have that slope is equal to -5. Now, even though you have the formula sheet, you still need to know how to use this formula. So basically, what we have here is going to be y minus y sub 1, which is -4. That's going to be equal to m, which is -5, times x minus x sub 1, which is 4. Okay, y minus -4, that's just y plus 4. We can distribute here, and if we do, we'll have -5 times x, which is -5x. -5 times -4 is going to be plus 20. And now the last thing we need to do is to get y by itself. And all that involves is subtracting 4 from both sides of the equation. If we do, these cancel. And we are left with y on this side, which is what we want. And over here, we're going to have minus 5x. 20 minus 4 is 16. And thank goodness all we have are integers here. Y is equal to -5x minus 16. Oh, and what was my mistake? I made a mistake. What was it? Check this out. Plus 20 minus 4 plus 16. So this should be plus 16. Now, what if you made that kind of mistake on a test? What would happen to you? Well, basically, this part would be worth 2 points. I would realize that you made a sign error. You would probably lose a half of a point. So no, I would not. Yeah, Hawks would grade it wrong, but I would recognize. I would be able to see what's going on there, and simply just grade the mistake. Okay, now we want to find the equation in slope-intercept form that passes through the points for these given coordinates. Once again, we start off with the exact same type of the exact same formula, the point-slope form. Y minus y1 is equal to m times the quantity x minus x1. There's only one slight problem. We don't know what m is, but that's okay. We have 2 points, -4, 4, and then we have -1 negative 2. We can use these 2 points to figure that out. Okay, and how can we do that? We can use the slope formula, which is the change in y, y2 minus y1, is divided by the change in x, x2 minus x1. All right. Let's call this point 2. Let's call this point 1. Don't know if that's the smartest move, but I guess we're going to find out. Okay, so y2 is going to be negative 2 minus y1, which is 4, divided by x2, which is negative 1, minus x1, which is negative 4. That will be negative 6 divided by negative 1 plus 4. That is going to be negative 6 divided by 3, which will give us negative 2. Make sure I didn't screw that up. So m is equal to 2. Now with that, we can actually use our point slope form. Which point do you want to use? It doesn't particularly matter. I'm going to go ahead and use this one right here. Okay, so that is going to be y minus y sub 1, which is going to be 4, is equal to 2, negative 2 times the quantity x minus negative 4. Okay, well, that's going to be y minus 4 is equal to negative 2 times x plus 4, or the quantity x plus 4. Distributing, we will have y minus 4 is equal to negative 2 times x plus negative 2 times 4, which is negative 8. I want to add 4 to both sides of the equation to isolate y. These will cancel. Whoa, that got me a headache. Over here I have y. On this side I have negative 2x. And then negative 8 plus 4 is not that. It's minus 4. So that should be what I get. We can actually check to make sure. What happens if I substitute minus 4 into this particular equation? That is going to be negative 2 times negative 4 minus 4. And that will be negative 2 times negative 4 is positive 8 minus 4, which is 4, which is what y is. So that actually should be correct. So we will have y is equal to negative 2. Well, hang on a second. Equals to negative 2 minus 4. Oh, negative 2x minus 4. All right, now we are coming to some of the stuff in section 4.5, and hey, we only got 3 problems left, so here we go. Now, first one, does this graph represent a function? Now, to do this, you can imagine the vertical line test, and actually you could use the vertical grids to do that. And notice that every single vertical grid will actually cross the graph exactly once. You can't see it here, but if we extended it, you would notice it. So this is indeed a function. Now we need to determine its domain and range. Now notice that these arrows go down and to the left forever, and this arrow goes down and to the right forever. So eventually it's going to take in every single real number on the x values. So the domain for this function is going to be all real numbers. Now to figure out the range, what you want to do is you want to look at the possible y values starting at the very bottom, which by the way is negative infinity, and going all the way up. And notice that this thing goes down forever. So the range starts at negative infinity. And since it's starting at negative infinity, we need to have a parenthesis there. And as we continue go up, as we go up the y-axis, we notice that the range will end at negative 1. That's the last y. That is the highest y value for which there's a graph. Okay, so it starts at negative infinity and it ends at -1, and we always are going to include -1. That is our range. Now to enter this in, what you need to do is you need to use your keypad. If you actually tried doing the parenthesis, it will just go ahead and immediately give you double parentheses, which you don't want. The only way that I know to do that is to go into your keypad and find the symbol combination that matches what you just wrote, which should be this one right here. Then you can put in negative infinity, comma, -1, and that will be your range. I hope. Yes, it is. All right. 2 questions left. Let's get rid of this bad boy. 1. Does this represent a function? Once again, look at the vertical line test, and it intersects the graph at least once. Now, these vertical lines don't touch the graph at all. That's okay. That's not a problem at all. As long as they hit the graph no more than once, we are good to go. What is the domain of this function? Well, to figure that out, what we want to do is we want to starting over here. We want to move along. Now, I think I said that incorrectly. To figure out the domain, what do we want to do? What we want to do is start over here, the negative x values, and we want to go up the x-axis until we see where the graph starts. And the graph starts here when x is equal to 0. So our domain is going to start when x is equal to 0. As we continue, we can see it will end when x is equal to 4. Okay, in that case, we are going to have 4 and bracket. That is our domain. You want double brackets, there it is, and then we want 0, 4. For the range, we're going to do the exact same thing with the y values. Starting down here, we're going to go up, and we notice that the graph begins when y is equal to -6. As we come up, we notice that the graph ends when y is equal to -4. That is how we compute our range. -6, -4. Okay, last question. First thing we need to do is we have this graph, and basically this graph is a collection of ordered pairs, and we need to enter in our ordered pairs. Okay, well, here is A. To get to A, we need to go up the x-axis to 6, and then down the y-axis to -5. So up the x-axis to 6, and then down the x-axis -5. We're down the x-axis 5, which of course is -5. I have to be careful with my use of double negatives. Okay, for B, we don't need to move on the x-axis at all from the origin, so that's going to be 0. But we do need to go down the y-axis to -7. So that's going to be 0, -7. For C, it's over here, so we need to go -3 in the x-axis. So that's going to be -3. And then we need to go down the y-axis 8. It's actually easier to figure that out by going -10, -9, -8. And then finally for D, we are going to get to there. We need to go along the x-axis to 6. So that will be 6. And then we need to go up the x-axis to 7. I'm sorry, up the y-axis to 7. There we go. Submit our answer, and lo and behold, I'm right. Okay, next question is, what is the domain for this particular function? Well, I didn't want that. I guess it would have been a good idea to write down our values. Well, actually, we don't need to. We can just start over here. Remember, it's going to be all of the x values. So if we come down here, we notice that we are at x equals -3. All right, so negative 3, comma. As we continue, we have x is equal to 0, 0, comma. As we continue on here, we have x is equal to 6, 6. That is our domain. Range, well, we can start down here and go up. Here we hit a point at negative 8, we hit C, so that's going to be negative 8, comma. Keep on going. At negative 7, we get B, negative 7, comma. When we get to negative 5, we have A, negative 5, comma. And as we keep on going up to 7, we get D, so that will be 7. So that should be our domain and range. And then finally, is this a function? The answer is no. Why? Because if we drew a vertical line right here, it would intersect those 2 points. The other way to look at this is this. Well, unfortunately, the previous answer does not display the coordinates, does it? Well, the other answer is if you actually listed the coordinate, if you listed out the coordinate, the coordinates, we would, or the relation, we would have this. We would have negative 3, negative 8 for C. Zero, negative 7 for B. We would have 6, 7 for D, and then 6, negative 5 for A. This would basically be our relation. And our relation has 2 ordered pairs with the exact same x value. So once again, this tells us not a function, or just simply the vertical line test would tell us that it's not a function. We would click no, and we better be right. There we go. And that is all there is to this, and that is all I have. And that is all I have for this particular video. If you are comfortable with those 13 questions, you should be able to ace this exam. If you have any questions, please feel free to contact me. I know that we're not having class on Friday, but this is your substitute for class, and I still expect you to be prepared and ready to ace this exam on Monday. Once again, any questions, send me an email. I will respond to them as quickly as I can. This is Bob Oil, signing off.